Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. Okay, we are doing Unit 4. So we are just going through all of these AP College Board questions because these are the ones that are made by the people that made the test. And so might as well practice this stuff by the people who made the test. This is good because this is a position, velocity, acceleration one. So all it gives you is this information. A particle moves along the x-axis, so its position at time t is greater than 0 is given by this. X of t is that quotient right there. So you got A, B, C, and D. So you have 4 parts of this. So pause the video, see how far you can get, and then knock it out. All right, let's see how I can do with this one. So position, velocity, acceleration, very important to review. This is one of the things that is the foundation of calculus and might appear on the AP. So let's try it. So this right here, we're trying to get to here because we know, I'm going to write here that position, velocity, acceleration. The rate of change of position is velocity. The rate of change of velocity is acceleration. So how do I go from here to here? How do I find this? So I know that v of t is the derivative of the position. So I'm going to use the quotient rule. Low d high minus high d low, which is 6t. Boom. And I'll put this in brackets because I need to distribute that negative, don't I? Yeah. And over the square of what's below. Bam. So I got to get this to look like this. So I get 70t on my numerator. So let's see if I can do it. Let's distribute here and let's distribute here. So this equals 6t to the third plus 16t minus, keep those brackets going, 6t to the third minus, is it 54? Yeah, 54. T. Cool. All right, all over square of what's below, right? All right, let's distribute this negative. So change the 6t to the third to negative and change the 54, the negative 54 to positive. So 6t to the third minus 6t to the third is 0. 16t plus 54t is 70t. Got it. So v of t equals 70t over 3t squared plus 8 squared. Boom, got it. Part A, done, easy. All right, part B. Is the particle, so the particle is moving along the x-axis, it's going like this, back and forth. Is it moving toward or away from the origin at t equals 2? So first off, where the hell is it at t equals 2? Is it to the left or the right of the origin? So this is 0. Where is it at t equals 2? So let's figure that out. So I'm going to figure out x of 2. Where is it? And then I'm going to look at the velocity to see whether it's moving to the left or the right, positive or negative velocity, wherever it is. So I'm going to figure out where the hell it is at time t equals 2. So that's 2 squared minus 9 over 3 times, I'm just plugging in this right here, right? 3 times 2 squared plus 8. So that would be 4 minus 9, which is negative 5. And this is 4 times 3, which is 12, plus 8, which is 20. So it's negative 1/4. So it's actually right here. So that's where it starts. So if the velocity is positive, it's moving towards the origin. If the velocity is negative, it's moving away. Okay, it'd be different if it was over here, if the position was over here to start. But we had a negative position, so we know that it's over here at negative 1/4 on the x. So now I'm going to go v of 2. So what direction is it going? So v is this right here. We just got it. And then that's the velocity. So 70 times 2 over 3 times 2 squared plus 8. All squared. So this is 140. And this is 20 squared, which is 400. So whatever this is, you don't really have to simplify this. You just know that this velocity is positive. And so the velocity is positive, and so therefore the particle is moving towards the origin. So it says explain, so we have to do a little explanation. Since x of 2 is less than 0 and v of 2 is greater than 0, so the position is to the left of the origin, but the velocity is moving to the right. That's essentially what I'm saying. The particle is moving towards the origin. At when? You gotta say when it is, because at a different time it could happen. So at t equals 2. Bam. All right, so that's part B. Got it. Fix it if you didn't get it, and then obviously do it again if you still need. All right, part C. I gotta get A of t and A of 2. So we know that V of t is 70t over 3t squared plus 8 squared, because we did that before. And we know that the acceleration is the derivative of velocity. Sorry, it should be t here. Derivative of velocity. So, this looks like another quotient rule. So low, d high, what's the derivative of that? Yeah, 70. Minus high. I'm gonna run out of room here. I'm gonna write it here. So it's 3t squared plus 8 squared times 70 plus low. So it's low d high minus high. Sorry, minus high. I always gotta sing that song. It helps me. Minus high d low. This is gonna be a chain rule. This right here. So chain rule is gonna be 2, keep the inside, times derivative of the inside, which is 6t, bam, over the square of what's below, 3t squared plus 8, all, this is squared, all of this now squared, bam. So this is A of t. So you could leave it like this if you want for A of t. So the only thing you have to do is now find A of 2. So it's probably in your best interest to simplify a little bit because you have to plug in 2. So let's do that. So that equals 70 times 3t squared plus 8 squared minus, so we got all this garbage going on in here. So 6t times 70, that's going to be 420 t squared times 2. 420 times 2 is 840. T squared, 3t squared plus 8 over 3t squared plus 8 squared, so that's to the 4th. Damn. Sorry, I can't do that to the 4th. So all I did essentially was I multiplied 70 times 6 times 2, which is 840, and then t times t. That's t squared, and then I have this sitting there right there. Okay, so now I can continue simplifying this. I can do da da da, I can do da 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 da, but I don't think I need to because I'm just going to plug in 2 right here and see what happens. So now I'm just going to plug in 2. So it's 70 times 3 times 2 squared plus 8 squared minus 840 brackets times 2 squared. Please don't do this when you're taking the AP. Make sure it's neater than this. Sorry, I'm a little scrunchy scrunch. I'm trying to get it on the same page so you can see it. And the AP, you can use as many pages as you want. Times 3 times 2 squared. Sorry, 3 times 2 squared plus 8. All over 3 times 2 squared plus 8 to the 4th. And you can leave it like this, actually. So I'm going to leave it like this, but I would actually write it neater up there. So I'll just plug 2 in here and I'm good. The actual answer, let's see what it is. Because we have the answers right here. Oh, we don't want that. The actual answer is all this fun stuff, negative 49 over 200. But if you leave it like this, you're good. Because all those are acceptable. All right? Pot D, almost done. Pot D, almost done. So basically all it says is, what is the position as t approaches infinity? So I'm going to take this, which is the position. So the limit as t approaches infinity of this, t squared minus 9 over 3t squared plus 8. So as I plug infinity for t, this minus 9 is not going to matter because it's going to be so small compared to this number. And then plus 8 is also going to be so small. So this is all I care about, these higher powers. And so this infinity squared divided by infinity squared is 1. And so the answer is 1/3. So as the time approaches infinity, the position of the particle is approaching 1/3. There we go. Got it. All pieces done. Thank you. Give me my points. Take care.